Hello and welcome to another episode of Slam TV. I'm Professor Roger Yang, and today we're going to learn about the binomial distribution. Luckily for you folks at home, we've got a very special guest for you. He's a man of impeccable taste and style. They broke the mold and then they made him. He turns lemonade into lemons. He's Professor Jay Cho. Hey Jay, how's it going?
Not bad, not bad. How are you doing?
Man, that lemonade sure looks refreshing.
I love lemonade. I'm actually a lemonade connoisseur a little bit.
Oh, really? Cool. So, how's your dream of being on American Ninja Warrior going?
You know what? My dreams have changed. I have more refreshing dream now. I want to create a lemonade empire. I want to be the Starbucks of lemonade.
Wow, you like to dream big. So what have you done to go about achieving this dream, Jay?
Well, you gotta start at the bottom, right? So I just applied for this food beverage quality control consultant position at a local lemonade stand.
Oh, wow. Did you get the job?
You mean career? And no, the competition was fierce.
What? You know more about lemonade than anyone else I know. You practically live and breathe lemonade.
And I drink it too.
I can't believe you didn't get that job.
I know. I suspect ageism.
Ageism? What's ageism?
I think I didn't get the job because I'm too old. 20 people got hired and only 4 of them were grown ups. And the rest of them, all kids.
How many people applied?
It was competitive, like thousands of applicants. Half of the applicants were adults and half of them were kids. I don't know what to do. It was my dream job. I mean career.
You don't think you're discriminated against, do you, Jay?
Only if there's somebody who can help us.
I know someone that can help us. She uses statistics to bring light to the darkness. She's a top attorney for the GUCLU, Grown Up Civil Liberties Union.
Oh, Guglu.
She's better known as Bone Joan, attorney at law.
You were just discussing a possible age discrimination case?
Does he have a case?
I was discriminated against. You hear me?
Well, we need to look at the data. We need to determine if it was just chance that out of 20 hirees, only 4 were grown-ups, or if there was some sort of bias.
How do we do that?
We can determine the likelihood of getting 4 grown-ups out of 20 purely by chance. If this is very unusual, it gives evidence that you have been discriminated against.
Determine the likelihood purely by chance? It sounds suspiciously like probability,
It does sound like probability.
It is probability. In fact, we need to use the binomial distribution to calculate the probability.
Binomial distribution? What does it do?
We can use it to determine how unusual it is to only have 4 out of 20 hirees being full-grown adults, such as yourself.
Can you tell us a little bit more about the binomial distribution, Joan?
It's phone Joan Esquire when I'm on the case. There are several requirements we need to check to see if your situation matches a binomial distribution. Once we know we have a binomial distribution, we can calculate the probability easily.
What's the first requirement, Joan?
Well, look at the word binomial. What prefix do you see?
Bi means 2, like bicycle, bicentennial, and bifocal. Where are my bifocals? I can't see a darn thing lately.
Nom means name in French, like how nominal data is basically data that's just names.
We.
The first property that we require is that you have a procedure with only 2 outcomes. We call these success and failure.
Oh, you mean like flipping a coin? A success would be getting a heads.
Yes, that works.
How about rolling a die?
How many outcomes are there from rolling a 6-sided die, Jay?
6?
Binomial situations call for procedures with only 2 outcomes.
What if you just care about rolling a 5?
If we make the outcomes of rolling a die, checking for a 5, or not, then we have 2 outcomes.
Oh, so rolling a 5 will be a success.
Exactly.
like whether they hired extremely capable, extremely good-looking, lemonade knowledgeable, grown-up like me, they'll be a success, right?
Obviously. In your case, a success would be hiring a grown-up. So the first requirement is that each trial have only two possible outcomes, success or failure.
A trial? What do you mean by a trial? A trial at court with judges and everything?
Not exactly. Each time we repeat the procedure, it's called a trial.
Is that the only requirement?
No, but we can create a binomial distribution from this if we had a few more restrictions. We also need to have a fixed number of trials. We call this number n.
Oh, okay. So if I repeat the procedure of flipping a coin 10 times, then the number of trials is 10?
Yes, so n equals 10.
Oh, so when company hires 20 people, they've repeated the selection procedure 20 times, so the number of trials for my case is 20.
Yes, so in your case, n equals 20.
Are there any other requirements?
Each trial must be independent.
Independent? What does that mean?
Two trials are independent if the occurrence of a success of one trial does not change the probability of a success in the other trial.
Wait, how are we going to show that each trial is independent?
If only we knew how many people applied.
Wait, Jay, didn't you say that thousands applied?
Yeah, at least 2,000.
Good! If they only hired 20 people out of 2,000, that's a small enough percentage of the population that we can use the 5% guideline for independence. If the sample size is no more than 5% of the population size, our sample can be treated as if it were independent. Since 20 divided by 2,000 is 0.01 or 1%, that's less than 5% of the population. So in your case, we can treat each trial, or hiring, as independent.
Is that it?
There's one more small condition. We need the probability of success in each trial to be the same. We call this number little p.
So like when I flip a coin 10 times, my n is equal to 10, and the probability of success is 1/2.
Yes, p equals 1/2.
So if you roll a die 15 times and try to roll a 5, the number of trial n is equal to 15, and then probability of success for each trial is 1/6.
Yes, so p equals 1/6.
How are we going to find p for this ageism discrimination case?
If only we knew how many grown-ups applied and how many kids applied.
Well, actually, the number of grown-up applicants are exactly the same as those young whippersnappers who applied.
Did you just say whippersnapper? What's a whippersnapper?
Oh, then the p is 1/2.
Great, that means we satisfy all the requirements of a binomial distribution.
Yay!
Now we can answer our original question.
Oh, wait, what was the original question again?
Jay, focus.
Oh, I'm trying. Oh,
We're trying to determine if it was unusual to only have 4 grown-ups hired out of 20.
Joan, can you help us calculate the probability of finding only 4 grown-ups out of 20?
You mean Phone Joan Esquire? Well, I have some friends that can help us. My overworked, underpaid paralegals.
Yeah, what do you want? Yeah, what do you want?
We need you to help us find a probability.
We only do binomial probabilities. We'll help you, as long as you satisfy the requirements.
We satisfied all the requirements for a binomial distribution.
Oh yeah? What's your n? Yeah, what's your n?
Our n is 20 because we hired a total of 20 people.
What's your p? Your p!
Our p is going to be 1/2 because half the people were adults and half the people were kids, so the probability of getting a grown-up is 1/2.
exactly.
How many successes?
We want to find the probability of having 4 successes.
What do you mean by find? Is the probability lost?
Sorry, I meant to say we need you to help us calculate the probability of having 4 successes.
Hold on. Let me grab our calculator. So you want to find the probability you have 4 successes, right?
That's right.
Exactly.
We need to use the binom PDF calculator function. You feel us?
We feel you.
Oh, so we got a probability of 0.00462.
Wow, probability of 0.00462? That's super low. That means it's very unusual. Wait, What's wrong?
Jay, I think we made a mistake.
What do you mean?
We calculated the probability of having exactly 4 successes, right? Exactly 4
And
grown-ups.
what's wrong with that?
Your whole thing is that 4 is an unusually small number.
Okay.
So getting 3 or 2 or 1 or 0 adults, that would also be, small.
Oh shoot. So are you supposed to include all these numbers because it's also unusual events?
Yes, so we really want to find the probability that x is less than or equal to 4.
Oops. How do we do that?
Hey, no. Before you go home, we got one more thing to ask you. We need your help finding the probability that x is less than or equal to 4.
What do you mean by find? Is the probability lost?
Fine. We need to calculate the probability of getting 4 or fewer successes. Do we still use Binomial PDF calculator function key?
No. We need to use Binomial CDF calculator function.
The CDF calculator function.
What's CDF? How is it different than PDF?
If we're trying to calculate the probability, or P, that x is equal to 4, we use Binomial PDF.
If we're trying to calculate the probability P that x is less than or equal to 4, use Binomial CDF.
The C stands for cumulative, which means we want to add all the probabilities less than or equal to 4 together.
Hey, Phone John.
We're going home.
So, is the probability unusual, Joan?
Good question, Roger. And you mean better phone, Joan Esquire?
I'm sorry. I mean, is the probability unusual? Better phone, Joan Esquire?
Usually, an event is considered unusual if the probability of it occurring is less than 5%, or 0.05. What we got is 0.00591, so getting 4 or fewer grown-ups is unusual.
Thank you, Your Honor.
I'm not a judge. You don't have to call me Your Honor.
Makes sense.
Well, so do I have a case?
By using the binomial distribution, we were able to compute the probability of getting 4 or fewer grown-ups out of 20 hires. Since the probability is so small, we consider this a highly unlikely event, which means age bias was likely.
It's great, Roger.
It's time to sue, baby.
We're gonna be rich.
So, whatever happened to that lemonade stand lawsuit?
It's a good news, bad news kind of thing.
What's the good news?
The good news is I won the court case. Yes. And I was awarded for lost potential wages. Not only that, I got punitive damage.
That sounds great.
I bought out the entire lemonade stand. I called it Chobox. You like the name?
I love that name. That doesn't sound so bad. So, what's the bad news?
Bad news is that these kids had to get off my lawn. However, they thought Chobox was sold 4 months ago. They started this raw kombucha stand right next to me. And they put me out of business in 2 days.
I'm sorry to hear that, Jay.
It's all good. They actually hired me. Now I work as a kombucha barista.